My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 217. In this lecture, we will try to understand how to represent a data set. So, now let's see how to represent a data set. Data set typically is written with a capital D. Generally, we used to represent by capital D. This is one way of. There are multiple ways. There are multiple ways of representing a data set. Multiple ways that you must understand. Multiple ways of representing a data set. We will try to understand two ways. We learn. I can say like this. We learn. There may be multiple ways. We learn two of the most used ones. Two of the most used ones. First one, I will discuss first one in this lecture, and second one in next. I will discuss in next lecture. I can say, let me say like this: data set is basically, what is data set? Collection. It's a collection of data points. I can say like this. Data set is collection of data points and its corresponding corresponding labels, let me say, or you can say classes. Isn't it? Corresponding labels or classes. We will try to understand. We will discuss. Just see, as I told you, my capital D equal to xi, comma yi. I varies from 1 to n. Isn't it? Your xi belongs to RD. If xi belongs to RD and your yi belongs to setosa, versicolor, setosa, versicolor, virginica. There are three labels, isn't it? There are three classes, otherwise three labels. Our data set contains n data points. What is the reason? Because I am writing from I equal to 1 to n. What does it mean? There are n data points. Like my first data, I am writing, our data set contains x1, y1 is the first point, x2, y2 second point. So on, I varies from 1 to n means so on. My nth point is xn, comma yn, isn't it? I have xi and yi. So for every xi, I can say, for every xi, I have corresponding yi, isn't it? Corresponding, I can say corresponding yi. I have n such data points. This n represents the number of data points. The number of data points in my data set. Here the moment I say xi belongs to RD, the moment I say xi belongs to RD, xi is a d-dimensional vector. What does it mean? It's a vector, column vector. What is the dimension of that particular vector? It is a d-dimensional vector. Can I say something like that? It is d-dimensional vector in this iris data set. In the case of iris data set, let me repeat, otherwise let me rewrite. In the case of iris data set, we had 4 features. Just try to recall our iris data set. How many features does we have? We have 4 features. Xi belongs to, therefore I can say your xi belongs to R4, isn't it? Which means for every data point, for every flower, for which you have taken 4 real values. Therefore, I can say, as I already discussed, this is a vector, column vector with features sepal length, sepal width, petal length, petal width. It's a column vector. As I mentioned to you, if you are not informed what it is, xi belongs to Rd. In this case, xi belongs to R4, xi belongs to Rd, basically means a column vector. Default, by default, it is column vector, isn't it? Column vector by default. For every column vector with 4 features. How many features? Sepal length, sepal width, petal length, petal width. I will repeat. For every column vector with 4 features have corresponding. It has corresponding. What do you have? Corresponding yi, isn't it? This is xi. This is corresponding yi. What is your yi? Your yi belongs to setosa, versicolor, virginica, isn't it? Virginica. These are the yi's. Of course, there are other types of yi's. Yi could be, there may be other types of yi's. Yi could be 0, 1, isn't it? Yi could be itself belongs to some real value. Your yi may belongs to some real value, isn't it? We will see different machine learning tasks for which there will be different values, but typically and not all the values may be real values. We will see these type of things in our future classes. Iris data set, in iris data set, everything is a real value because your sepal length, sepal width, petal width, all these are real values, isn't it? Petal length are all real values. We will see more variations of data. D is data points and D is data points and class labels. I can say, as I told you, my D equal to, I can say xi comma yi. What is my xi? Xi is data points. This is data points. I can say data points. This one is data points. This one is class labels. I can say like this. Class labels, isn't it? I have n such data points. If I say I equal to 1 to n, how many such data points I have? I have n such data points and class labels. So where my each data point belongs to Rd, I can say. In the case of iris, it is R4. Isn't it? R4, which means it is a 4-dimensional vector, again a column vector, which consists of sepal length, sepal width, petal width. Yi now belongs to 3 types of flowers. This yi belongs to 3 types of flowers: setosa, virginica, isn't it? This is one way of representing the data set. There are other ways we will see. One other way, very useful way of representing data set, but this is one way of representing data set. The other very useful way of representing data set I will discuss in my next lecture, that is in lecture number 218. That is next lecture. Thank you very much.